Good afternoon and once again welcome to our YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, we will be introducing ourselves to topic 1 of Pure Mathematics 1. And the topic is trigonometric ratios. And we will start with let's talk something about the cosine rule. The cosine rule. The cosine rule can be used to work out missing sides or angles in triangles. And this version of the cosine rule is used to find a missing side if you know two sides and the angle between them. Generally, we know the cosine rule to be a squared equals to b squared plus c squared minus 2bc cosine of a. So if you could be having a triangle that looks like this, and that is A, this happens to be B, and this happens to be C, of course, the side opposite a certain vertex is small a, and this B, this is side B, and of course, this is side C. So A squared is equals to B squared plus C squared. You can see those are two sides plus C squared minus 2bc, the cosine of the angle opposite that side we are finding. And in most cases, we have just been able to use this formula, but do we know how it has been? It has come about? And we can use standard trigonometric ratios for right angle triangles to prove the cosine rule. And this is just what we want to do. So prove. If we have a general triangle that may look like this, that is a triangle, and that triangle is going to have a perpendicular height like that, and call it H. And this is vertex A, so this side is A. This is vertex B, this side is B, and this is vertex C, so the whole of this side is actually C, but because it's divided at point X, so that part of the side is X, and therefore this part is C minus X, because the whole side is C. And using the Pythagoras Theorem, we know that we can talk about h squared using triangle, or rather using triangle ACX. H squared plus x squared is equals to b squared. Again, using triangle CBX, using triangle CBX, we can go ahead and say h squared plus c minus x squared, this is the other base of the triangle, is equals to a squared. And from here, you can actually make h squared the subject of the formula and say, and we can call this equation 1, and you can call this equation 2. And from equation 1, let's talk about from equation 1. From equation 1, h squared is going to be b squared minus x squared. And from equation 2, h squared is equal, because both of them have h squared, is equals to a squared minus c minus x squared. So at the end of the day, we are going to be convinced that b squared minus x squared is exactly equals to a squared minus c minus x squared. And that is just like it. And if we are interested in making the a squared, at least to capture the cosine rule, if you are interested in making the a squared probably the subject to capture the cosine rule, we are going to say a squared is equals to b squared minus x squared plus 3 minus x squared. Expanding that part, it's going to give us a squared is equals to b squared minus x squared plus c squared minus 2cx plus x squared. Of course, it goes without saying that a squared is equals to b squared minus x squared plus c squared plus c squared minus 2cx. You realize that minus x squared cancels with plus x squared. And at that point, we would wish to say something. So this x squared is not there anymore. So we are having, this is going to be b squared plus c squared minus 2cx. But we realize that as much as b is a whole side of our triangle, c is a whole side of our triangle, and a is a whole side of a triangle, x is not a whole side, it's just part of the side. So if we may want to express x in different way or using the general and primary trigonometric ratios, we can simply say, considering triangle ACX, and we're going to talk about considering triangle ACX, we are going to say cosine of angle A is given by adjacent, which is now x, adjacent of a hypotenuse, which is b. And from there, you can already see that x is b cosine A. So if we substitute this, in this part, we can easily say that a squared is equals to b squared plus c squared minus 2c, and x is now b cosine A, b cosine A. And of course, generally, that is the cosine rule. Rearranging this, then we have a squared is equals to b squared plus c squared minus 2bc, the cosine of A. And that is just what we have been saying is called the cosine rule. Now, you can make anything the subject of the formula here. You can even we can talk about 2bc cosine A. If you cross it over to the other side, it's going to be b squared plus c squared minus a squared. And by extension, if you clean up a little bit, you're going to have the cosine of A itself is b squared plus c squared minus a squared, everything over 2bc. And that can be that. So anything can just be written as the subject of the formula. So this is the general subject, the general cosine rule, just like it is illustrated there, but you can reduce it to this level if you at all you would want to calculate the size of a certain angle A. So you can rearrange this and have b squared is equals to a squared plus c squared minus 2 ac, and cosine b, that can be done. And even c squared is equals to a squared plus b squared minus 2 ab, and the cosine of c. Each one of these can be rearranged. Each one of these can be rearranged in this format just to find the angle. And having done that, then we have been able to prove the cosine rule. So in our next video, we will be able to use this cosine rule in calculating the sides of a triangle and as well as the angles. Again, visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and subscribe, and of course share widely, and let us work together. All right.